So let's see what it does with some database related topics. So here we're given ChatGPT 3 database tables, and we're asking it to find students who took courses from their own department. So here it's just gonna actually consult its training data and try to solve the problem. The nice thing is that it's not gonna just throw a SQL at you, it's actually gonna try to explain its logic and how the query is gonna be written. So select from students, join enrollment, on a student ID, join courses, on course ID, basically where the department is equal to the department. And it's just gonna explain the query for you. It says that this query joins these 3 tables based on the student ID and the course ID, and then it filters the rows where the department of the students matches the department of the course. Here's a better solution, I would argue. Select star from students. Let's just follow the same structure. Students, natural, join courses, natural join enrollment, natural join courses. Now we know that natural join is going to look at the columns with the same name and join them. So I'm not going to need a where clause there. So the query you provided is simpler and more efficient way to find the students who took courses from their own department. It's going to tell you why it's more efficient, which is really impressive, to be honest. It's like, but it's just going to cost you also that, natural join could be a problem if, if you change the schema of a database, and then it's better to use to specify the columns in which you would like to join. But I would argue that relational database schema is fixed. So natural join should be fine. And as you can see here, kind of acknowledge that the relational database schema doesn't change much, and that the column names, if you know them, then it's okay. But they're saying it's also worth noting that natural join can be less error prone by using explicit join conditions. It's still arguing it's important to be aware of potential downsides to natural join in case column names are not unique and the data types are different. Such but I'll argue again, but performance wise, natural join save natural join reduce or remove redundant join columns, which is more efficient. And now let me fix my typos: redundant and efficient. Okay. So now it's going to say, yeah, that's right, because it eliminates the need to include redundant join columns in the result set. And when you use natural join, the database will automatically match those. But again, it's going to just keep saying, however, may be relatively small and may not be significant enough to justify the use over explicit join conditions. And by the way, I'm not trying to convince it otherwise, right? Because I agree with what the model is saying, because it's just consulting so many different resources about databases, and it's just like looking at the common wisdom of what people are saying out there, and that's what it's trained to do. So this conversational style with an excellent English structure and grammar with very strong logic, it's just scary, right? You know, you feel that you're talking to more than a human. I'm a database professor, and I don't think that I can respond this quickly. You know, I'd be able to write stuff more complicated than this, but then the way it's just generating the answer is impressive. And notice here, when I provided the first prompt, I just said that assuming that you have these three tables, I did not even mention what's in these tables. So it just immediately made the assumption that the student table has an student ID, and the enrollment table is what is connected with students through the student ID and connected through courses, the course ID. And that's actually a schema that I have in one of the homework and exam databases I have. So I'm not sure if the model was able to find this information somewhere, or this is a more common example that the database was able to kind of consult online resources and basically get the answer. Look at the funny thing here now, which is not 100% accurate, right? We also teach a like graph and document database. Convert the previous query to a Neo4j, which is a graph database. So let's see. They clearly say the cipher is the query language, and look at that. Now it's just telling you that there's a node student that has the relationship enrolled in, which is correct, to an enrollment node. Well, yeah, that could be the case. You can do it in many several ways. And there's a teacher's relationship between a course, which I disagree here, right? So this match clause who have a relationship enrolled in, an enrollment has a relationship teaches a course. So it's not clear for me that the relationship between course and enrollment should be teaches. Right, but otherwise it has written a syntactically correct cipher query. Cipher is the language used by Neo4j, right? So it's a correct. So now I'm going to argue, I'm going to copy the code and paste it here, and I would say student enrolled in a course, and then I'm going to remove this part. So just like simplifying this, removing the enrollment and making it more of a relationship, and then have this as C, and let's just see what happens here. You're correct. My apologies to make a mistake. Previous response, the correct cipher query to find students who took courses from their own department is what I provided, right? So it's kind of look at your answer and says, you know what, man, yeah, he knows what he's doing. But I'm not sure to what level it is you can actually convince it that her wrong answer is the correct answer. You've seen my conversation with it when I had this discussion about natural join and how natural join is for me much better, even though I'm convinced about what it's saying, and it kind of stick to its ground and continue doing what it's doing. But now with Neo4j, it kind of apparently acknowledged that my query is better. Now let's just like convert the SQL query into MongoDB. MongoDB is a document database based off JSON. So it is using the aggregate pipeline, which is quite sophisticated pipeline, right? And that's what you need to use. The lookup is the way to join two documents. Assume there's a document with the name enrollment. So we're going to use the local field from the students, which is the student ID, and the foreign field is student ID, and then unwind enrollment. That's like breaking down the array of documents returned after the join. And then now we're looking up courses with enrollment.course ID. The foreign is an underscore ID, assuming that the course is identified by an ID. And then we're saying match department of the student equals to the course.department. And this is just impressive. I mean, this is a correct, query. I've done research on building systems that, does a lot of work to be able to do something like this. And of course, I can argue that our systems are better because it uses basically a theoretical model. Like we use data log to represent the query, and then from data log we convert it to SQL, Neo4j, and MongoDB. But this is just looking at the previous query, and it just completely build the data structure. So it has the database that is used for the SQL query. It kind of build this document model and run a query against this database. Can you show the MongoDB for documents for the above query? So I'd like to see if they're, they already have a model of like what these documents look like for the MongoDB. Oh my God, look at that. Here is an example of like a student ID, name, department, and then a few examples of like 3 students, and then now the enrollment, student ID enrolled in a course ID. That's pretty much it, right? The enrollment is a connecting relation, right? And then basically here is a few examples, and finally the course is going to have the course ID and the course name, mostly the course department as well. It's just wonderful. I mean, I don't need to create slides anymore, right? But then, the scary part about this is just that the students will just come and say, here is a database, can you write me this query? And then we're doomed. So this is very interesting, especially for writing database code. I'm really impressed to see how accurate this model is in terms of converting queries among different databases, being able to represent database for the query above, for the SQL query above, or something. Let's just see if it's just gonna take this. So here is like the SQL databases, and it's just gonna write down the tables for you. Look at that. It is mind-blowing, right? I was like, this is the textual model. How is it going to represent the table? Here you go, MySQL or SQL style in a prompt, right? You're in a console writing down SQL. Here is your table. Here are your tables. I am scared at this point and excited, and it is too much to digest at this point. I need to take a few days off and think about this amazing technology. So once it's done, it's just going to go ahead and show us the courses table. And in the meanwhile, I'm just going to ask it to show me the Neo4j graph for the above example. I'll let it finish, and I don't think it worries about that. Oh, well, it's not allowing me until it stops generating. So that it's just telling you about like what is the logic, how things are connected. Keep in mind, this is just an example in the actual structure of the tables in your database made up for. Note that SQL database primary key, the way you can identify each row in a table, and it's used as a reference in the join query. Thank you so much. Then show me the graph, and here you go. It just keep track of the above conversation. I'm just trying to see if it's just gonna build the database based on the changes I made, or is it gonna? Oh yeah, it's actually using the same model that I gave, right? It's showing you the node, the properties within each node, which is the ID, name, and department, and also showing you the course, and just enrolled in should has probably some property, but it's just ignoring them at this point, which is fine for this example. So notice initially that the ChatGPT did not realize that we don't need the entity enrollment because it's a connecting entity. In a graph, I just can use an edge. And once I corrected that and I asked for an example, it is using my example. It's using the correction I gave the model, and it's using the database after my correction, which is quite impressive. Well, it's been interesting to play with ChatGPT for database purposes. I can see that there's some value with an instructor supervision in terms of teaching databases and teaching database models. If I have the ability to train this model and have some guided exercises for students, this could be actually an opportunity to provide some hands-on educational material to students. But on the other dark side, we also have to be a bit worried about cheating, and then we have to be more smart about how we design our algorithm. A fun thing to do is to ask ChatGPT how to prevent students from using ChatGPT for cheating, right? And then it's just gonna tell you, or any cheating is a complex issue that requires multiple faceted approach. Here are some strategies. Thank you, ChatGPT. Make sure that you tell students, educate them, monitor plagiarism using, violation, kind of academic integrity violation tools. Do randomized test questions. Make sure you have proctored exam to make sure the students are not using ChatGPT. Encourage collaboration with students because that creates a culture of academic integrity. Things we actually try to do in our classrooms, using different forms of assessments, tracking students' usage of the tool, and whatnot. It is important to note that even with these strategies in place, it may not be possible to completely prevent cheating. However, implementing a combination of these strategies can help to reduce the likelihood of cheating and create a culture of academic integrity. It's going to be fun to see what ChatGPT will grow to be, and I can see some potential for using ChatGPT in education. Thank you so much, and we'll look forward to explore more topics related to ChatGPT in databases, and hopefully actually some use cases for using ChatGPT in education. Thank you so much.